Hello guys, this is Akash. Welcome back to this YouTube channel Nursery with Lecture. In this video, we are going to start another chapter, that is Matrices and Determinants. In the top 10 question series for the JEE Advanced 2023, I already completed the 3-4 chapters in this series top 10 questions. So you can get the benefit from it. And if you didn't subscribe the channel for the notifications and also hit the bell icon so that you can receive the notifications when I upload this type of videos. And also if you didn't join the Telegram group, join the Telegram group because it is very important. And the videos which I am going to upload, I will pre-upload in the Telegram channel so that you can know what type of sessions are going to happen before searching in the YouTube. So because the YouTube is a distraction, and if you didn't use the YouTube in a right way, you cannot get the maximum of it. So it is very important to know the updates and what are the videos are going to upload. So join the Telegram group. And also now let's get into this video and discuss the first problem. This problem is determinant problem. Determinant problem, and we will discuss line by line. And we will know what is the approach we have to implement so that we can get the answer. First, we have to read the question very carefully. This is the previous year JEE Advanced question, and also in this top 10 question series, I am bringing the questions which came in the previous years. So these questions are not randomly picked. These questions are the JEE Advanced previous year questions. This question is in the 2018 paper. So it is very important to do this type of question. The first question is the total number of distinct values of x for which this determinant is equal to 10. So we have to solve this determinant and we have to report the distinct values of x for which this value is equal to the 10. So first what we can do, by observing these columns, we can easily implement the approach, that is by separating the determinant, that is x, 2x, 3x, x square, 4x square, 9x square and 1, 1, 1, distributing like this. Again x, x square, 2x, 3x, 4x square, 9x square, x cube, 8x cube, 27x cube is equal to 10. And if you observe carefully here, we can take common in this column x, and if you take column x square, this column, and if we take x into x square as common, what is left? 1, 2, 3, 1, 4, 9, 1, 1, 1. Plus here I am taking x as common, x square as common and x cube as common. So what will outside? X into x square into x cube, and 1, 2, 3, 1, 4, 9, 1, 8, 27 is equal to 10. So what is x into x square into x cube? It is x power 6. And what is x into x square? It is x cube. So we have to solve this. So I am rubbing the previous one so that I can write here x cube into, I have to find the determinant for this. What is the value of determinant here? 1 into 4 minus 9 minus 1 into 2 minus 3 plus 1 into 18 minus 12. So how much it is? Minus 5. Here it is minus 1, it is plus 1, and here it is plus 6. So the answer will be here 2. So for this total it is 2. So I can replace here 2. 2x cube, and here we have to solve now. We have to solve this determinant. Here it is 1 into 27 into 4. It is 7 4 28, 4 to 8, 9, 10, 108 minus 72 minus 1 into 27 into 2, 54. 54 minus 24, and again plus 1 into, here it is 18 minus 12. So what it is? Here it is approximately 28 plus 8, it is 36 minus, here it is 30 minus 30, here it is plus 6. So total it will be 42 minus 30, it will be 12. So finally here it is 12. Complete, we can rub this and we can replace 12. So what we got finally? We got finally 2x cube plus 12x power 6 equal to 10. This equation we got finally. Now we have to solve. By taking common 2, what we will get? X cube plus 6x power 6 equal to 2 into 5, 2 will get cancelled, and 6x power 6 plus x cube minus 5 equal to 0. And if you observe carefully, if I take x cube as t, what it will become? 60 square plus t minus 5 equal to 0, and 60 square plus 60 minus 5t minus 5 equal to 0. If I split the middle term by using the coefficients of t square and the constant term. And if you take common 60 plus 1 here, and if you take common minus 5, it will be t plus 1. And if we take t plus 1 as common, it will be 60 minus 5. What we got? T equal to minus 1 or t equal to 5 by 6. What is t? X cube. X cube equal to minus 1, and for here x cube equal to 5 by 6. So how many values we got? Here x cube will be minus 1, but here we got only one distinct value. Here x cube equal to 5 by 6. Here also we got only one distinct value, that is x equal to 5 by 6 whole power 1 by 3. This is only one value, and here it is also x equal to minus 1 whole power 1 by 3. Here also it will be minus 1 only. Here it will be 5 by 6 whole power 1 by 3. So we got only two values only. So how many distinct values of x is possible for this determinant to be equal to 10? There are only two. So the answer is 2. Like this you have to solve. Basically, we have to use the determinant properties by for splitting this, and after splitting we have to take common x square, and in the second determinant we have to take common x square, x cube. So by taking common and equating to 10, we got the two distinct values, that is 2. And that what are the distinct values? That is minus 1 and 5 by 6 whole power 1 by 3. These two are the distinct real values we got. The first question is completed, and it is determinant question. Total there are 10 questions. Out of 10, 5 questions are matrices and 5 questions are determinants. First I am going to solve determinants so that it will be easy for moving. And the second question is, let k be a positive real number, and let a equal to 2k minus 1 2 root k minus 2 root k, 2k minus 1 here. This is a value, and b equal to 2k minus b value equal to 0, 2 root k 0, 2 root k minus 2k 0 minus 2k. So this is the value of b, and they are given if data of adjoint A plus data of adjoint B is equal to 10 power 6, then greatest integer of k is. This is a question, very important question. Carefully observe. Let k be a positive real number. So k is a positive real number. It is okay. Now they given two matrices, A equal to this thing and B equal to this thing. By observe this thing, it is very clear. That is the diagonal elements are 0. So what type of matrix it is? It is Q. It is Q symmetric matrix. And we know for odd order, what is order here? 3 cross 3. For odd order, what is the determinant of this matrix? The determinant of this matrix will be 0. So if you observe carefully, the relation they given, that is det of adjoint A plus det of adjoint B equal to 10 power 6. What is det of adjoint? Suppose if you take x, what is det of adjoint x? It will be mod x whole power order minus 1. So what is the order here? 3 cross 3. So it will be mod A whole power 3 minus 1, because order is 3, plus mod B whole power 3 minus 1 equal to 10 power 6. What is mod A? What is mod A? 3 power minus 1. Here it is square. Here it is B square equal to 10 power 6. But what is the value of det of B? The det of B is 0 according to the skew symmetric matrix properties. So det of A square equal to 10 power 6. Now we have to find det A. To find det A, it is very complicated to multiply each and everything. So we have to apply properties. Up to now, understand? Finally we got mod A square equal to 10 power 6. This is the thing we got. Now we are going to apply some properties for A to find the determinant. 2k minus 1. So simply I am applying here only. The first property is C2 tending to C2 minus C3. The first property. And the second property is R2 tending to R2 minus R3. First I am doing this, say after this. Why I'm doing this? Because to simplify this, we have to apply properties. First time I'm going to apply C2 tending to C2 minus C3. Why C2 minus C3? Because this positive, if we subtract, it will be negative. That is 0. 0, here 2 root k, here 2 root k, here 1 minus 2 root k, here minus 2 root k, and here it is minus 2 root k, here it is 2k plus 2 root k, and here it is minus 1. The first property is completed. Now the second property, R2 tending to R2 minus R3. R2 tending to R2 minus R3. Now it will transform into 2k minus 1, 0, 2k minus 2 root k. Here it will be 4 root k. Here it will be 1 minus 2 root k minus 2k minus 2 root k. Actually it have to be plus na. Why? Sorry, we done C2 minus C1. Sorry, it is mistake. 1 second. We have to apply C2 minus C3. So what is this column is same, 2 root k minus 2 root k, it is same. What is here? C2 minus C3, it will be 0. It will be 1 plus 2 root k. It will be 2k plus 1. And here it will be same, 2 root k minus 2 root k minus 1. Now we are going to apply R2 tending to R2 minus R3. Here it will be 2k minus 1, 0, 2 root k, same. R2 minus R3, this thing we have to minus 4 root k, and if we minus these things, what I will get? I will get 2 root k minus 2k, and if I do minus here, I will get like this, and here minus 2 root k, 2k plus 1 minus 1. This is a thing. Now we can somewhat able to make this easy to multiply. That is 2k minus 1 into 2k minus 2 root k minus if we have to multiply these things. Minus 2 root k plus 1 into 2k plus 1. Now it's completed, and here it is plus 2 root k into 4 root k, 2k plus 1 minus 2 root k minus 2k into minus 2 root k. If you observe carefully, here these terms 2k plus 1, 2k plus 1 we can take common, and when we multiply these all things, finally we got 2k plus 1 whole cube. Because here 2k plus 1 if we take common, and by these two subtractions we can directly get into this 2k plus 1 whole cube. You can solve this thing and you can write the answer, because it is easy to find these things. We have to just multiply. You can directly multiply, but what are the need of these properties? By using these properties, you can be able to solve this problem very easily without worrying, because when we start multiplying these things, it will take up to 5 minutes to solve for the value of k. Now it is easy for us because we apply two transformations, C2 tending to C2 minus C3, R2 tending to R2 minus R3. So we got directly. That is 2k plus 1 whole cube. So the final answer is 2k plus 1 whole cube. What is the value of det? Equal to 10 power 6. This relation we already got in the starting. But what is det A? It is 2k plus 1 whole cube, and it is whole square equal to 10 power 6. So 2k plus 1 whole power 6 equal to 10 power 6. 6 cancel. 2k plus 1 equal to 10. K equal to 9 by 2. That equal to 4.5. The value of k is 4.5. But they asked greatest integer of k. What is greatest integer of 4.5? It is 4. So for this question the answer is 4. Like this we have to solve. First we have to identify the skew symmetric matrix. Why it is skew symmetric matrix? Because the diagonal elements are 0 and these two elements are opposite of signs. You can easily find what in the properties of the skew symmetric matrix. The diagonal elements are 0 and the things will be of same signs or different signs depending on the problem. And here you can see here the symmetric matrix. What is symmetric matrix? If A is a matrix, A transpose equal to A, it is symmetric. A transpose equal to minus A, it is skew symmetric. These properties you have to understand. Here. The second question completed. Next, third question. Third question, for the problem which we done in the that is before, that is also battery determinants question. For a real number alpha, if the system 1 alpha, alpha square, alpha 1 alpha, alpha square alpha 1, x y z equal to 1 minus 1 1 of linear equations has infinitely many solutions. Infinitely many solutions, then 1 plus alpha square equal to how much? This thing you have to find. It is a very important question. This type of questions are repeating for a real number alpha. So alpha is a real number. The first thing is clear. If the system of equations, this is a A matrix into X matrix equal to, that is AX equal to B or AX equal to D, you can write augmented matrix. These equations has, these linear equations has infinitely many solutions. What is the condition for infinitely many solutions? That determinant should be equal to 0. This matrix determinant should be equal to 0. That is 1 alpha, alpha square, alpha 1 alpha, alpha square, alpha 1. What is the determinant of this? That is 1 into 1 minus alpha square minus alpha into alpha minus alpha cube plus alpha square into alpha square minus alpha square. It is 0. So 1 minus alpha square minus alpha square plus alpha cube. So alpha cube, no, it is alpha power 4 here. Alpha sorry guys, the music player is on. It is in the system, so it raises the voice. It is a alarm which I kept to complete this session, and it is gone to the YouTube only. Sorry guys for that. So here we got alpha power 4 minus 2 alpha square plus 1 equal plus 1. This is the determinant. It should be equal to 0. This determinant is equal to 0, and now what we find? This thing we already find. But another thing, in Cramer's rule, what are the conditions for infinitely many solutions? Infinitely many solutions conditions are, first of all, the determinant should be is equal to 0, and the values of d1, d2, d3 also should be equal to 0. Understand? So the first condition we find, and after the first condition we have to find another condition. That is, when we substitute this d in front of this, that is 1 minus 1 1 alpha 1 alpha square alpha 1. But you can directly see here, there is no need to find d1, d2, d3. You can directly see here, what is the form of this? It is alpha square minus 1 whole square. Is this correct? It is equal to 0. So alpha square equal to 1, alpha equal to plus or minus 1. Now we have to check carefully whether alpha equal to 1 or alpha equal to minus 1. When alpha equal to 1, you can clearly see that 1 1 1 1 1 1 1 1 1. This matrix is going to happen like this. This is the no solution condition because the planes are parallel. So it is wrong. So alpha equal to 1 is rejected, alpha equal to minus 1 is accepted. So if alpha equal to minus 1, what is the value of this? 1 minus 1 plus alpha square, that is 1 square minus 1 whole square. So 1 minus 1 plus 1, 1 minus 1 cancel, so answer will be 1. So like this you have to solve. We have to firstly apply the condition of infinitely many solutions. What is the condition from the Cramer's rule? From the Cramer's rule we already know that if Ax equal to D, the d1, d2, d3 values are equal to 0, and also the determinant of d is equal to 0. So like this you have to solve. The third question is completed. Now fourth question. This question is really big, guys. Let alpha, beta and gamma be real numbers such that the equations. They given some equations, guys. I will write here. X plus 2y plus 3z equal to alpha, 4x plus 5y plus 6z equal to beta, and 7x plus 8y plus 9z equal to gamma minus 1. Like this here, the equations are given. Like this, the equations are given, and next, now they are asking, and these equations are consistent, that is, they have some solution, is consistent, and now they are asking, let capital M matrix they given, alpha 2, gamma, beta 1, 0, minus 1, 0, 1. This is another matrix. This is another matrix. Now they are asking, what is the magnitude of M? This is a question. What is the magnitude of M? First of all, we have to consider these equations. What they are saying? They are saying that these equations are consistent. So whether they have the unique solution or they have the infinite solutions. Whether they have the unique solutions or they have this this thing. So now we are going to consider the matrix, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. So when you solve this thing, 1 into 9 5 is 45 minus 48, minus 2 into 36 minus 42, plus 3 into 32 minus 35. Here it will be minus 3. Here it will be minus 6 plus 12. Here it will be minus 3 minus 18. Is this correct, guys? 3 into, here it will be minus 3 minus 3. It will be minus 9, not 18. Because it is 3 now. 3 into, here it will be minus 3 minus 3. Okay, now it's correct. The answer will be 12 minus 12, it will be 0. So when determinant is equal to 0, what we can get from this? When the determinant is 0, these solutions are not unique solutions. These solutions are infinitely many solutions. So the first thing is clear. The first thing is clear. And also, it is obvious. It is very obvious that when the solutions are infinite, the planes are related to each other. Suppose the plane, the equations, suppose the equation 1 plus lambda times equation 2, it will be related to equation 3. So like this, it is very important to understand. Like this, it is very important. So the first equation is x plus 2y plus 3z minus alpha plus lambda times second equation 4x plus 5y plus 6z minus beta. And now this thing is equal to equation 3, that is 7x plus 8y plus 9z minus gamma plus 1. It is related like this. Now we have to find the values. It is x. Here it is 4 lambda x. If we take xx common, it will be 1 plus 4 lambda. And if we take y common here, it will be 2 plus 5 lambda. And if we take z as common, it will be 3 plus 6 lambda. And the values here is minus lambda minus alpha minus beta equal to 7x plus 8y plus 9z minus gamma plus 1. So when you observe this thing, the LHS and RHS part, these two are equivalent or equal, we can say. So we can compare these things, that is 1 plus 4 lambda divided by the quotient of x, that is 7, is equal to 2 plus 5 lambda divided by 8 and 3 plus 6 lambda divided by 9. And the next thing is, and it is equal to, and this thing is equal to alpha plus beta. Is this alpha plus beta? Is this correct, guys? It is not alpha plus beta, it is lambda here. Lambda is also present now. So it will be, first of all, it is minus of alpha plus beta lambda divided by this thing, minus gamma plus 1. Minus, if we take, if we throw minus to downside, it will be gamma minus 1. So like this, the thing total we got. Now we have to solve this equation. We have to solve this equation, that is 1 plus 4 lambda. 1 plus 4 lambda divided by 7 is equal to 2 plus 5 lambda divided by 8. When you solve this thing, 8 plus 32 lambda equal to 14 plus 35 lambda. It will be it will be minus 6 equal to 3 lambda, 3 1 3 2, so lambda equal to minus 2. We got lambda equal to minus 2. Yes, we got. And they are asking mod m, that is the determinant of m. So it will be alpha and next minus 2 into beta and next plus gamma into plus 1. Okay, alpha minus 2 beta plus gamma value we have to find. And we got gamma lambda equal to minus 2. When we substitute lambda equal to minus 2 here, it will be alpha minus 2 beta divided by gamma minus 1. And when we equate to this thing, that is lambda equal to minus 2 here, it will be minus 1 here. So alpha minus 2 beta equal to minus gamma plus 1. So alpha minus 2 beta plus gamma equal to 1. What is alpha minus 2 beta plus gamma? It is mod m. And what is it is equal to 1. So the mod m equal to 1. So what is the answer here? The answer is 1 here. Understand, guys? It is very important to understand. The fourth question completed. Basically this question is very large, and in this question there is no only one question. There are nearly 3 questions. That it is nothing but the paragraph type. In this paragraph type, they given very bulk amount of matter and they ask nearly 3 questions. Out of 3 questions, the important question is this thing. And we completed 4 questions. 1, 2, 3, 4. Yes, 4 questions we completed. And the 50th question is really interesting. You don't need to solve, but just you have to use logic. Let P be a matrix of order 3 cross 3 such that all the entries of P are from the set minus 1 0 1, then the maximum possible value of the determinant of P is how much? Very interesting, guys. Pause the video and solve by yourself. It is really interesting. So basically they given, let P be the matrix of order 3 cross 3. They given one matrix. Suppose A1, A2, A3, B1, B2, B3, C1, C2, C3 are the elements in this matrix, and it is 3 cross 3 matrix. What they are asking? Such that all the entries of P, all entries all from this set. So these A1, A2, A3, B1, B2, B3, C1, C2, C3 are the values which are from the set minus 1 0 1. Basically the values will be only from these values, that is minus 1 0 1. Then the maximum values of the determinant of P. Suppose it is P, and what is the maximum value of determinant of this? What is the value of determinant? Maximum value of determinant. Determinant max equal to, first we have to find the determinant. So what is the determinant? A1 into B2 C3 minus B3 C2. One thing, minus A2 into B1 C3 minus B3 C1, and another thing plus A3 into B1 C2 minus B2 C1. So now don't want to solve this thing, just observe this thing. How much the value may be? Suppose if we take minus 1 0 1 here, these entries, if it is maximum, I want this thing as an addition. I want this thing as an addition to want a maximum. So this thing as an addition, A2 should be equal to minus 1. It is clear. A2 is minus 1. It is clear. And also to want maximum, this minus should also be plus. So I can take B3 as positive or C2 as negative. So but I am taking here. I am taking what? I am taking here. I am taking B3 as negative. B3 as negative, that is minus 1, and C3 as plus 1. Because if we take B3 as minus 1, here it will be helpful for us. Because minus into minus plus, and I am taking C1 as plus 1. And here, if B1 C2 B1 C2 it is normal 1 minus B2 C1. What is B2? B2. Suppose if we take B2 as 1 but C1 we take 1. So 1 minus 1 0. So this entire will be 0. There is no maximum here. We cannot search of maximum. So the complete answer will be, suppose if we take A as 1, A into 1 plus 1 and plus 1 into 1 plus 1. So answer will be 2 plus 2. That is answer will be 4. Like this you can solve. So the maximum possible determinant will be 4. You can search of many possibilities, but the maximum determinant should be equal to 4. This thing you have to keep in mind. The determinant questions are completed. Now it's time for matrices questions. The 5 questions are got completed in this determinants. 6 question. Now the matrices. They given that A is 2 cross 2 matrix. A is 2 cross 2 matrix. A is 2 cross 2 matrix such that A is 2 cross 2 matrix such that trace is 3 and trace of A cube equal to minus 18. And then det A is equal to what? It is very important, guys. This is very large question, but I simplify this because JEE Advanced committee is very interested in explaining the things to you. What is mean by trace? These things are even explained in this exam paper. They explain what is trace. What is trace? If we take 2 cross 2 matrix, suppose these elements, the sum of the diagonal elements is known as trace. They explain this thing before this question. So if you consider a matrix A, B, C, D, this is of 2 cross 2 matrix and it is the matrix name is A. They are saying that such that this trace, that is A plus D diagonal elements value is equal to 3. This is one thing. And A cube. Now we have to do A cube. A, B, C, D, A, B, C, D, A, B, C, D. If we do this, what we will get? A square plus AC and AB plus BD. Here AC plus DC. Here BC plus D square. This thing into AB, CD. We want only trace values. So I can directly just multiply this thing and this thing and this thing and second thing. So what I will get? A cube plus one second, guys. Here it will be BC, na? Yes. ABC plus here ABC plus BCD. This thing I got in this side. Leave it, guys. This thing you can leave. I want only this thing and this thing because they given A cube trace. This is A cube we are finding. So to find this thing, I have to multiply just this thing. AC into AB, that is ABC plus BCD and next BCD plus D cube. So we got these two things. Now just simply add these two things. That is A cube plus ABC plus ABC plus BCD plus ABC plus BCD plus BCD plus D cube. Now A cube D cube, what we can write? A plus D whole cube minus 3AD into A plus D. This is a formula. And here ABC, ABC, ABC and BCD. There are nearly 3 ABC. 3 ABC and 3 BCD. And from this if you take common, what we can take common? 3 BC if we take common, A plus D if we can got. And what is the value of A plus D here? 3. We can substitute here. 3 cube, that is 27. 27 minus 3 AD into, what is AD? 3. 3 3 is a 9. So it will be 9 AD. Plus, and here it will be, A plus D, here it will be 9 BC. And this thing is equal to minus 18 they given. And if we take common, If we take common and shift to right and left, it will be minus 18 plus 27, how much? It will be 45. 45 equal to 9 into AD minus BC. AD minus BC equal to 5. What is AD minus BC? The determinant of A. The determinant of A equal to AD minus BC. So AD minus BC we got answer 5. So what is the value of determinant here? 5. Like this you have to solve. This is the sixth question. Next, seventh question. The number of 3 cross 3 matrices M with entries from 0, 1, 2 such that the sum of the diagonal elements of M transpose into M is phi or, and they given options. This is single correct question, guys. 128, 126, 135, 162. This question also very interesting. This type of questions came regularly in JEE Mains 2022 and JEE Mains 2023. What they are saying? The number of 3 cross 3 matrices M. The number of 3 cross 3 matrices, basically M is a 3 cross 3 matrix. 3 cross 3 matrix. Suppose if we consider it as A1, A2, A3, B1, B2, B3, C1, C2, C3. This is M. Now they are asking, suppose these entries with entries from 0, 1, 2. Basically from this, the entries are only 0, 1, 2 from the set of 0, 1, 2 such that the sum of the diagonal elements of M transpose M. Suppose if the entries are 0, 1, 2 only and they given that sum of diagonal elements in M transpose into M is equal to 5. They given. So we have to find M transpose into M. What is M here? This thing. And what is M transpose here? It is A1, B1, C1, A2, B2, C2, A3, B3, C3. So I have to multiply these things. So basically the reverse order. Basically this matrix should be here. I just written here. This matrix should be here. I am repeating. This matrix should be here because it is very important to understand. Now I have to multiply these two things. When I multiply, what I will get? These things should be multiplied to these things. So A1 square plus A2 square plus A3 square. Leave this thing, leave this thing, leave this thing. Here it will be B1 square plus B2 square plus B3 square. Leave this thing, leave this thing, leave this thing, leave this thing. Why I am leaving these things? Because these things are not needed. And if you do calculations, it is waste of time. And here it will be C1 square plus C2 square plus C3 square. Because A1, A2, A3 multiplying with A1, A2, A3. A1 into A1, A1 square, A2 into A2, A2 square, A3 into A3, A3 square. So this thing I got. And these are the diagonal elements. They said that the sum of these diagonal elements, is equal to 5. A1 square plus A2 square plus A3 square plus B1 square plus B2 square plus B3 square plus C1 square plus C2 square plus C3 square is equal to 5. They given. Now we have to check the possibilities. Now we have to check the possibilities. What are the possibilities? These things, the entries should be 0, 1, 2. So when, if we consider the sum will be 5, I can consider like this. 1, 1, 1, 1, 1 and zeros, 0, 0, 0, 0. I can consider this one case, and I can consider another case where 2 is taken and the remaining things are 1, 0, 0, 0, 0, 0, 0, 0. These are the two cases. These are the entries. Now we have to arrange these things. First of all, these things. it is clear that in this thing it is 9 factorial divided by, this is 5 factorial into, this is 4 factorial. This is one case plus, and here it is 9 factorial divided by 9 factorial divided by what it will be, this thing is 9c5 and here it should be 9c7. So it should be 2 factorial because it is 2 factorial into how many zeros are repeated, 5 factorial, and the to change, that is to distribute, we have to multiply 2 factorial, and here we have to multiply 1 factorial. So basically this is the answer. And when we solve this thing, this is 9 factorial, 9 into 8 into 7 into 6 into 5 factorial divided by 5 factorial into 4 factorial, it is 24. 5 factorial will cancel, 6 1s are 6 4s are 4 1s are 4 2s are 7 2s are 14, 14 9s are 9 4s are 36, 126. First thing we got 126. Second thing, 9 into 8 into 7 into 6, 2 factorial will get cancelled, 9 8s are 72, 72 into 7 6 are 42. So basically I will got here it is not 5 factorial, it is 7 factorial. Sorry, it is 7 factorial. 9 factorial divided by 9 into 8 into 7 factorial divided by 2 factorial into 7 factorial into 2 factorial. 2 factorial cancel, these two things cancel, 9 72. 126 plus 72, it is 8, 9 198. So the answer will be A. Like this you have to solve. Now 8th question. 3 questions left, guys. This thing completed, this thing completed, this thing completed. Now if m equal to 5 by 2, 3 by 2, minus 3 by 2, minus 1 by 2, then which of following, this question came in my JEE Advanced paper, then which of the following matrices is equal to m power 2022. Options are A, here B, C, here D, 3034, 3033, minus 3033, minus 3022. And 3034 minus 3033, 3033 minus 3032. Here it is option C. Option C is 3033, 3032 minus 3032. Options are little bit similar, but you have to carefully pick the answer. 3032, 3031. Minus 3031 minus 3030. Okay, guys. This is a question. They given a matrix. Now we have to find m power 2022. We cannot multiply. We don't have that much time to multiply m power 2022 times. So we are just find the pattern. So I am doing m square. 5 by 2, 3 by 2, 3 by 2. Minus 1 by 2, I am multiplying with 5 by 2, 3 by 2, minus 3 by 2, minus 1 by 2. So when we multiply, we got m square equal to 5 by 2 into 5 by 2, it will be 25. No, it is not 25, it is 25. We have to multiply like this now. It will be 25 by 4 and it will be minus 9 by 2. And here it will be 15 by 4. 15 by 4 and here it will be minus 3 by 4 and here it will be minus 15 by 4, here it will be plus 3 by 4, here it will be minus 9 by 4, it will be plus 1 by 4 and m square we got as this thing will be 4 here, and here it will be 3, here it will be minus 3, here it will be minus 8 by 4 minus 2. This is m square, and like this you have to do m cube. There is no place, guys. I am just writing here m square and rubbing the upside things. So we got m square here, and now we have to find m cube. M cube is 4, 3, minus 3, minus 2 into 5 by 2, 3 by 2, minus 3 by 2, minus 1 by 2. Like this you have to multiply. Now when we multiply, we will get m cube. 4, that is 4, 20 by 2, that is 10. 10 minus 9 by 2. 12 by 2, it is 6, minus 3 by 2, minus 15 by 2, plus 3, minus 9 by 2, plus 2. And when we solve this, we will get 11 by 2. It will be 6 to 12, 12 minus 8 will be 9 by 2, 11 by 2, 9 by 2, and it will be 9 by 2 minus 9 by 2 here, and it will be minus 5 by 2. So these things, this is a cube, that is m cube. So when we observe clearly, this is m square, this is m cube. What is the difference we got? By substituting 2 we got 2, by substituting 3 we got 11 by 2. So if you observe carefully, one pattern is repeating here for this thing, that is 3n by 2 plus 1 is repeating. Because when we substitute 2 here, 2 will get cancelled, 3 plus 1 4. And when we substitute 3, 3 2s are 9, 9 by 2 plus 1, it is 11 by 2. So it is clear that it is 3n by 2 plus 1. And again, and after this thing, 3n plus 1 divided by 2, and here if we observe, it will be 3n by 2. And here it will be minus 3n by 2. And here it will be minus 3n by 2 plus 1. Yes, it is correct. This is the pattern applying here. And now, and if you find the new matrix, that is m power n, we will definitely got 3n by 2 plus 1, here 3n by 2, here minus 3n by 2, here minus 3n by 2 plus 1. Some people are still doing, that is 3, 4, 5, 6, up to 10 they did, and they left the question. Like me, because I didn't even recognize the pattern here, and simply now substitute 2000 to 2. When we substitute 3 into 2000 to 2 by 2 plus 1, 3 into 2000 to 2 divided by 1, that is 2, 2 plus 1, like this you have to do. 1011, it will be 3033 plus 1, it will be 3034. Here it will be 1011, it will be 3033. And here 1011, it will be minus 3033, and here it will be 1011, it will be minus 3033 plus 1, it will be 32. So where is option? 3034? Yes, 3034, these two options are wrong. 3034, 3034, it will be plus, so option A is correct. Minus, 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 minus. Yes, option A is correct. Like this you have to do. This is 8th question. This is 8th question, and now 9th question. 2 questions left, guys. Let beta be a real number. Let beta be a real number. Consider the matrix A equal to B0, beta 0 1, 2 1 minus 2, 3 1 minus 2. And if a power 7 minus beta minus 1 into a power 6 minus beta, a power 5 is singular matrix, then 9 beta is. This question also came in my paper. Let beta be a real number. They said first of all beta is a real number. Consider the matrix A. They given the one matrix and they are saying this complete matrix, the new matrix is a singular matrix. What is singular matrix? When the determinant of that matrix is equal to 0, that is like this. This determinant is equal to 0, then it is said to be singular matrix. Now if you observe carefully, I can take common a power 5, it will be a square minus beta minus 1 into a minus beta is equal to 0, and I can split these things, that is a power 5 a square minus b minus 1 a minus beta is equal to 0. Now I can write these things as how I can write a plus I into basically I have to write here how I can write a plus I, and I have to write in as a product here. How we can write as a product? If we separate this, a square minus beta a plus a minus beta. Now we have to find a way to write. Basically if we take common here, a minus beta will be, yes, it will be a minus beta. So a plus I into a minus beta, yes, a plus I into a minus beta, these things equal to 0. Here mod a is not equal to 0. Definitely they given this mod a is not equal to 0, they given in the question only. So these things should be equal, and these things also, especially a minus beta should be equal. That is a plus I here, a into a square minus beta a plus ai. Yes, it is plus ai and minus bi. Yes, it is correct. And these things should be equal to 0, and especially a minus beta should be equal to 0. A minus beta is equal to 0. Here beta, it will be beta I, we can write a minus beta into I equal to 0. So what is a? They given beta 0 1 2 1 minus 2 3 1 minus 2 minus what I can get minus beta into I. Here it will be minus beta 0 0 0 minus beta 0 0 0 minus beta. So I have to solve this thing. I have to solve this thing. So it will be, when I subtract this, what I will get? Beta minus beta. So basically I already written. So just I have to addition. It will be 0 0 1 2 1 minus beta minus 2 3 1 minus 2 minus beta. Yes, now we have to take the determinant of this. What will it will be? 1 into 2 minus 3 plus 3 beta minus 1 plus 3 beta equal to 0. So it will be 3 beta equal to 1, beta equal to 1 by 3. So beta equal to 1 by 3. What is 9 beta? 9 into 1 by 3. So it will be 3. So complete answer will be 3. Like this you have to solve. You have to think what is meant by singular matrix. The singular matrix is nothing but the matrix should be equal to 0. The determinant of this matrix should be equal to 0. After that we have to apply the cases. The 9th question is completed. Now 10th question. Last question, guys. Let M be a 3 cross 3 invertible. That means it is invertible. The inverse of this matrix is existing. That is, M can exist as M inverse. The meaning of this is like this. Let M be a 3 cross 3 invertible matrix with real entries. And let I let I denote the 3 cross 3. Let I denote the 3 cross 3 identity matrix. M inverse equal to adjoint of adjoint M. Then which of the following statements is or always true? They given, this is a multi-correct question. A, B, C, D, 4 options are given. Multi-correct. So there are more than 1 or 2 or 3, maybe 4 may be correct. You have to check carefully. M square equal to Y and adjoint M whole square equal to Y. Let's solve one by one. So basically guys, let M be the 3 cross 3 invertible matrix. I already said it can exist the M inverse with real entries, and let I denote the 3 cross 3 identity matrix. Now they given M inverse equal to adjoint of adjoint M. So I am multiplying adjoint M both sides. It will be adjoint M adjoint M. This is the main step here. And after that here, and after that this thing can be adjoint M into M inverse equal to the complete thing we can write as mod adjoint M into M. This thing we can write, and we know that this thing is here adjoint M equal to M inverse. I can multiply M into M, so it will be M square, and here it will be M power n minus 2, that is 3 minus n minus 1. What is the property says, what is adjoint M, what is mod of adjoint M? It will be mod M whole power n minus 1, so it will be square into M square. Adjoint M equal to mod M whole power 4. So like this I can solve. And now here it is adjoint M. If I take this thing, mod M square equal to mod M power 4, and we can, from this we can easily say that mod M equal to 1, that is data of M equal to 1. It is clear. And when data of M is equal to 1, we can simply square of this, that is M square, the matrix M. What we will get? M square equal to I. This C is also correct. And now now what we have to do? And we have to square this. When we square this, we already know mod M square equal to I, so I square, so it will be I. So from these 3 things only the complete answer is having the solution. So it is very important. So answers will be B, C and D. These 3 things. So answers are B, C and D. Yes, it is correct. So finally guys, we have completed the 10 questions of the matrices and determinants. So if you like this video, hit the bell icon and subscribe to this channel, and also share to these friends, your friends. It is very important so that your friends can also be benefited. And also guys, if you want this type of sessions more, you can write in the comment section what are the videos you want. I can make the videos in that topic. So don't worry guys, and also all the best for your examinations. And join the Telegram group. There you will get all the notifications as well as the notes and problem practice sheets. It is very important to join the Telegram group. So that's it for this video guys. Thank you.